Thank you for being here. It's such a treat getting an opportunity to talk every year. I know GIDS is just celebrating their 10-year anniversary, but I've been coming to Bengaluru now twice a year for the past 8 years. And I've also had the opportunity to visit user groups in Chennai and Hyderabad and Pune. And so it's really given me an opportunity to fall in love with your nice country. As a ThoughtWorks employee, we have offices all throughout India. And so I hope that I'll have an opportunity to spend more time in India, not just here with GIDS. But this is my last presentation for GIDS. But there is a free event being held at the Bengaluru office for ThoughtWorks. If you have not had an opportunity to swing by their booth, please do. It's a free event, and we will be focusing exclusively on conversational UIs. I'll be giving the same talks I gave here, but if you didn't have an opportunity to see them, this would be another opportunity, and it's a free event. You just have to register with the ThoughtWorks booth out in the front entrance area. But this is my last opportunity to talk to you today as an official GIDS instructor, and so we're going to get a chance to talk about HTTP 2, which is interesting because so much of what I do and so much of the talks that you hear at conferences like this are very high up the stack. We focus on frameworks extensively, don't we? And then if we're not talking about frameworks, sometimes we'll talk about programming languages and give you new features of that. But very rarely do we make it farther down the stack. And so this talk is going to be a little bit different. I love the mean stack. I talked about the mean stack today. We talked about it at almost the tip of the pyramid, but we're going to be moving a little bit farther down that hierarchy and talking about the transport layer, not frameworks or languages. But we can't talk about HTTP 2 without talking about this gentleman. Are you familiar with Tim Berners-Lee? I'm sorry, Sir Tim Berners-Lee, yes? He is the inventor of the World Wide Web. He was working at CERN back in the late 1980s, and he said, I want to come up with a way that we can publish scientific documents in an open, non-proprietary way. We want to make sure that these scientific documents aren't tied up in a proprietary word processor like WordPerfect or a Me Pro or WordStar or one of those other word processors that are no longer with us, right? So Tim Berners-Lee invented the idea of HTML, hypertext markup language, the way we mark up these documents. He invented the first web browser. You know what he named it? World Wide Web. It was a terrible name for a browser, isn't it? We programmers aren't very wise, are we? We do things like name databases SQL. Who would do something like that? Yeah? But he also invented the first web server. But what we're going to talk about today are none of those things. We're going to talk about the protocol he invented to send information back and forth between the web server and the web browser he created. And while the payload was HTML, which he invented, the transport protocol, the hypertext transport protocol he invented was HTTP. So that's what we're going to talk about here. Tim Berners-Lee is an interesting fellow. I think you can learn quite a bit about languages and frameworks by learning a little bit about the creator of those frameworks. I think you can learn a lot about Java by learning more about James Gosling and what motivated him. When he was working on the Java project, he was trying to create software that would run on cable set-top boxes. Normally, you had to write that in C, which means you had to compile it for every individual set-top box. Well, he came up with this idea. He called it Oak originally, but eventually it became named Java. And Java gave them the ability to write that application once and run it anywhere, WARA, but running on any of those cable set-top boxes. What's amazing is I was working at Time Warner Cable just a few years ago, and they're still using Java on cable set-top boxes. So just by learning a little bit about the history and the background of Java helped me become a better Java developer. I can say, did you know that we're doing exactly what this language was designed to do? And they said, you're kidding, right? No, and then you tell that story. Well, I want to take us on a similar journey with Dr. Tim Berners-Lee and understanding a little bit more about the web. We're going to spend time talking about the history, but of course, the main intent of this talk is for us to understand HTTP2. But to understand HTTP2 and the new features and the capabilities it offers, we need to make sure we're very clear about everything that came before it. This is a book by Tim Berners-Lee. And it's fun because it tells a lot about the history and the mindset and things. So a lot of the stories I'm going to be telling you today are from this book. But Weaving the Web by Tim Berners-Lee is one that I recommend. It's a nice, fun read. But if I've spent most of this conference talking about what we can see above the water, oh, get ready. We're going below water level now and talking about some things that we don't normally talk about. A dear friend of mine and a colleague, Glenn Vanderberg, once said, it's important for developers to understand one layer of abstraction below where they do their day-to-day work. So when I hear him say things like that, I think that this is where we spend most of our time in React and Angular and HTML and CSS and JavaScript. This is where we get an opportunity to go one layer of abstraction below where we do our everyday work. So HTTP2, to set the stage, is the second version of HTTP. We've been using HTTP 1.1 since the last century. We've been using HTTP 1.1 since the late 1990s. But in between HTTP 1.1, there have been things like Speedy, S-P-D-Y. And so each one of those will help us better understand the capabilities of HTTP2 by understanding how we got here. There are a lot of websites that are using HTTP2 right now. An amazing number of websites. HTTP2 was finalized in 2015. So it's already been out a couple of years. And so being able to recognize technologies that are actively being used out in the wild by major websites like this. But I encourage you to do a little of exploring on your own. There's a wonderful Chrome extension called HTTP2 Indicator. Again, we're not good at naming things, are we? But the HTTP2 Indicator does exactly what you might expect it to. This little lightning bolt right here tells us exactly what technology any given website is using. So I'm at Google right now, and we can see that it's Speedy and HTTP2 and Quick as well, QUIC. This is something else we'll talk about. Now I can click on this icon and get a much more detailed report of everything that's going on. But a lot of times it's helpful just being a little information radiator. This little green asterisk, or excuse me, green lightning bolt will tell us what these various websites are running. So Google is HTTP2. Let's see what Twitter is running. If I can get to Twitter. We get to Twitter, and they're running HTTP2. Can you see that? HTTP2. Let's go to Facebook. HTTP2. So it's helpful just having that little indicator in place just so we begin seeing how many websites have actually adopted this. And it's wonderful that all these other websites have adopted it. It means that it's ready for prime time, and after a couple of years, we have good examples of best uses, best practices about this as well. But HTTP2 isn't some scary future technology. It's technology that's here and now today and being active use. HTTP2 is supported by every major browser on the planet. So it's up to us to catch up and find ways to begin taking advantage of the new offerings of HTTP2. But I mentioned to you already, this is our agenda. We're going to try to understand what HTTP 1.1 offers us to begin with. If you spent any time building out RESTful APIs, HTTP 1.1 will feel very familiar to you. Next, we'll move on to WebSocket. Are any of you using WebSockets in your apps? A few of you, very good. Not many, though. It represents a technology that's well established, been out for a number of years, but a very different architectural model. Whereas HTTP 1.1 is request response, WebSockets are streams and events. And the reason I mention WebSocket is because when that came out, that inspired Google through Speedy and Quick to do some interesting things. And Speedy and Quick are what ultimately became HTTP2. So we're seeing a good kind of progression of web technologies, and each previous member on the list influenced the next one in significant ways. So let's begin with HTTP 1.1. So, hypertext transport protocol. HTML is hypertext markup language. So given the name, we understand what it's meant to do. It's meant to send web pages around. We spent a lot of time in our OCI network layers here. I haven't looked at this stuff since university, but it's always good revisiting, help place this in perspective. So the link layer, of course, are things like Ethernet, or 802.11b, or N, or G, or any of those kinds of things. So that's just the link, the connection itself. We know that IP addresses are the way we get to various websites. We also had an opportunity to talk yesterday in the Littlest Cloud about UDP. So TCP is connection-oriented, but UDP is broadcast-oriented. The reason I bring this up, the U in quick stands for UDP. So we'll be revisiting this again. But this is where we're living with HTTP. Once you have an address and a way to get there, we want to start sending web documents around. So, defined in a couple of standards, 1997 is when we got HTTP 1.0, and there was a minor revision in 1999 which gave us 1.1. But this protocol hasn't changed in what? Almost 20 years. So, HTTP 1.1 is very clearly a request response protocol. We can also describe it as a connectionless protocol, because when I type in www.thirstyhead.com in my browser, that's going to send a request, an HTTP request, an HTTP GET request. And that web server is going to respond, send the web page back down, and then sever the connection. And this was architected this way, this was designed this way with great intent, because we wanted something to be massively scalable. And if I'm trying to support tens or hundreds or thousands of users on an individual server, The way the original web servers were written was one thread per request. If you've ever done any configuration on an Apache, remember you would set up a thread pool. And so you would configure 25 threads, 25 requests, and what that meant was the 26th person had to wait, right? So we were motivated by this architecture to request, respond, and move on to the next request. We were really trying to optimize for multiple users in a connectionless way. So, these hyperlinks, being able to link from document to document, means that you could start on your server and very quickly go to another server, and you can click on a link and go to another server. And we even know that the way you compose an HTML document is you could be pulling images from one server and CSS from another and JavaScript from another, right? So we know that this scales incredibly well. Yeah. These concepts weren't invented by Tim Berners-Lee. He was inspired by Ted Nelson on the Xanadu project in the 1960s. They, in turn, were inspired by a project out of the 1930s that was trying to do something very similar, but ironically with microfiche, right? But the whole idea here is we've got this connected network. And the way we get pages and images and documents and CSS is through the GET method. And the very first web server supported exactly one verb, get. And it supported exactly one payload, HTML. But you can see that over time, this has expanded. Now web servers can serve up a number of different MIME types. It can serve up not only text HTML, but CSS and JavaScript and images and MP3 files and all manner of things. But we started with a single payload. And similarly, we found that GET was great. That solved the happy path case. But what were some of the other verbs we might want to add? So HTTP 1 included not only GET, but post and head. What's the difference between get and head? Have any of you used the head argument before, the head action, the head verb? No? So get will actually download the entire resource. If I come out here real quickly to a command line, and bust it up so you can see it. If I do a curl, verbose, get on HTTP thirstyhead.com, from the command line now, I'm doing the same thing that happens when you type in a URL in a browser. I'm going to be making an HTTP GET request to that URL over there. But what's nice about doing this at the command line, especially with the verbose flag on it, is I can turn around, waiting. You can do it. I believe in you, network. Oh, please don't fail me. The demo gods have been so happy with me the entire time I've been here. Oh my goodness. All right, well, while my network is deciding to connect, the head method would have just returned the headers. It wouldn't have returned the body or the payload, it just would have returned the headers. So it's a great debugging utility to go in and say, oh, let me do an HTTP GET from the command line, so when I do it from a browser, I can make sure I really see what's going on. And maybe I'm just interested in making sure headers are being passed, authentication headers, good things like that, so you can use the head verb. Notice that there was a post as well. This was the first time that we could not only retrieve documents, but insert new documents. So the post, I think of it like the post office. You're sending something through the mail, right? You're sending a new letter out, and then the postman or the postwoman, the post carrier, right, is the get version of it. They bring the mail to you. Yeah? You're familiar with CRUD, I'm sure, right? Retrieve, update, delete. Well, we've got 2 of the 4 verbs taken care of. We now have the create, that's post, and the retrieve, that's get, but we were missing the update and the delete, right? So in 1999, when they modified the spec, they said, here are a couple more verbs that we can use. Put is for updates, and I always can tell because there's a U in put and there's a U in update. Delete is just what it sounds like. And there are very other verbs in here as well. One of them is options. As we added more verbs, one of the things you can do is you can ask a web server, hey, what verbs do you support? And if you sent an options request, it would list all the various verbs it supported. This is important because later on, there were things like WebDAV. That was Microsoft's addition to the party, and there were a lot of additional verbs that came out of WebDAV. So HTTP is written to be extensible as well. It's easy to add new verbs, and that's why the option keyword is so important, so we can understand what actions are available to us. So we've talked about get and post and put and delete. And what's interesting is we've been talking about web pages. But later on we said, what if instead of serving up HTML payloads, we served up JSON payloads, JavaScript object notation? And do you see how we were able to take the same 4 verbs and repurpose them for web services the same as we were using them for web sites or web pages? I love this form of reuse. Did any of you do any SOAP development back in the day? What was interesting about SOAP is that it gave you some different capabilities, similar capabilities, Obviously, you could do full CRUD through SOAP. But SOAP was meant to be transport independent. So you could bind SOAP to HTTP, but you could bind it to a bunch of other protocols. Did any of you ever bind SOAP to anything other than HTTP? No. And what was more disheartening about SOAP over HTTP is you only used one verb. You only used post. And what that meant is that you weren't respecting the way the web worked. The beautiful thing is if you understand how web pages work, you already understand how RESTful web services work. You don't have to learn anything else. But with SOAP, it broke some of the basic rules of HTTP. Specifically, we began talking about the idempotency of these verbs. Isn't that a fun $20 word to trot out? Makes you sound smart, doesn't it? My computer instructor, when I was first learning this, he was from the South, so he didn't say idempotent. He said idempotent, like impotent, right? You know, oh, that's an idempotent page. I said, really? Is that impotent? And he said, no, idempotent. Let me explain to you what that means. It means you can make the call over and over again, and it won't give you different results. So if you think about making an HTTP GET, and this is true in either web pages or web services, if I say HTTP GET, I want to get all of the delegates who attended GIDS in 2017. I should be able to make that once, twice, 3 times, n times, and the act of doing an HTTP GET should not change anything, right? I might be logging it, I might be doing authentication checks, but the idea is just by asking for that data, it's idempotent. It doesn't change the state of the server. Other verbs, like post and put do change the state of the server, right? So while we recognize this using fancy words like idempotent or impotent, right? Idempotent. It allows us to say, would you ever want to do something like that? No. Because something like that, that delete is being done over an HTTP GET. And what we're saying is HTTP GETs ought to be able to be bookmarked and sent out. What if I sent someone a hyperlink and they clicked on it and it deleted that? That'd be awful, right? And here's a more common way that we understand idempotency. If you are here in your web server and you hit back, right? All of those gets can be replayed because they're idempotent. It doesn't matter if you request it again and again and again. But when do your browsers throw up these dialog boxes? For a post. They're saying, in effect, are you sure you want to buy that book from Amazon again? Are you sure you want to change your password again? Are you sure you want to delete that relationship status from Facebook, right? You know, there are those kinds of things going on. So something like this demonstrates how important the semantics of those verbs are. We've mentioned curl here already, but I like bringing this up because curl is available to us on Windows, Linux, Mac. As web developers, this should be an important tool in your toolkit. Because as we demonstrated, we can go up. That's what I was hoping to demonstrate for you live. By doing a curl at the command line, it showed me not only all of the conversation that was going back and forth between the browser and the server, but it also got me the payload down below. And if I had a working internet connection, I could have done the same request using a head instead of a get, and it just would have returned the headers. Does that make sense? Yeah. Yes, please. Say again, I'm sorry? Yes, put should be, right? Because you're updating something. If I update my last name to Davis, that's something I can replay over and over again. Excellent clarification. Yeah. Of course, you can see these things inside of any good browser as well. I've been doing web development so long, I remember when we didn't have developer tools baked into our browser. That was not a fun time to do web development, right? But now we've got this embarrassment of riches going on in here. And so there are all manner of tools. There's a great Chrome plugin called Postman. I don't know if you've worked with that. But that's a way that you can do RESTful get, put, post, delete kinds of things. You can do it from a console. You can do it from a command line. But the important thing is we should be comfortable with this. This is the one layer of abstraction below where we do our everyday work, and we should at least be familiar with what's going on under the surface of the water. So here's something else we'll be able to recognize. Let's see if I can see it here. Yeah, no, I won't. At the end of this, we would have seen the connection dropped. Because remember we said this is request, response, drop the connection. And so these persistent connections were not solved in the protocol. They were solved in a clever little workaround called what? Cookies. Cookies. If I log into Gmail, say, show me my messages, Gmail's going to say, who are you? Scott@thoughtworks.com. Log in. Great. When I send the next request, because it's stateless, Gmail's going to say, who are you? So I just logged in. I want to see the inbox. And then when I see a message in the inbox, I clicked on that message, Gmail would say, who are you? I said, this is annoying. How many times do I have to tell you who I am? So we have cookies, which is a way when we log in, Your server can create a cookie and it says, hey, you know what? I want you to pass this back and forth with every request response. A cookie's like a little sidecar or a goiter to every request, right? So every request and response has that cookie, and that's a very clever way, a very well-established way, to make a stateless protocol stateful. Yeah. So, this leads us to WebSockets, because WebSockets are a W3C standard as well. WebSockets are well supported across, every major browser. But what makes WebSocket different than HTTP is it runs on top of HTTP, but WebSocket is stateful. It's a persistent, durable connection. And what's interesting about WebSocket is you don't use HTTP verbs anymore. You already have that connection. So what happens is messages stream along there. And it's full duplex, so messages are bidirectional. And what you set up are event listeners. Stick with me on this. WebSocket is to HTTP as SOAP is to REST. WebSocket is to HTTP as SOAP is to REST, in that there are no standard verbs in WebSocket, just as there are no standard verbs in SOAP. SOAP gives you the ability to create any method and publish it in the WSDL, the Web Services Description Language. And similarly, WebSocket allows you to listen to any arbitrary event. But the most important thing out of this is the full duplex connection that's not only running over a single TCP connection, but it runs over HTTP as well. You can run WebSocket on your web server. And when that request comes in, we're doing an HTTP GET right now to the chat endpoint using HTTP 1.1. But this is the request coming up from the client. The client says, hey, here's where I'm going, but I would like you to upgrade my connection from HTTP 1 to WebSocket. I am asking that you do that. The other thing that's interesting is WebSockets are secure by default. HTTP 1.1 is a plain text protocol. WebSocket required us to encrypt the pipe. Your server will respond not with the HTTP 200 that you're expecting, right? The OK, or the HTTP 404 not found. Did I tell you I'm staying in room 404 at the hotel? I can never find my hotel room. I don't know what the problem is. Yeah. But this now is responding with a 101 saying, I'm going to switch protocols on you. We're going to upgrade ourselves from HTTP 1.1 to WebSocket, and here are the handshakes, and everything moves on from here. I was the chief web architect at an audio company before I became principal engineer at ThoughtWorks. And as you can imagine, audio does a lot with streaming. We want to stream audio over the wire. So we ended up doing quite a bit with WebSockets. Because as you can imagine, if we want to listen to the volume of a speaker, we don't want to make HTTP GET requests and poll, right? What we want instead is to set up a durable full duplex connection and start streaming these events down. And maybe we would subscribe to just the decibel level. So that's something that would be generated many times a second, so we could generate a little graph showing you what the actual volume was of that. But we also would set volume decibel thresholds. So we want to make sure, if you've heard microphones squeal before, squeak, squawk, very, very loud, that could be an event we could listen to as well. We don't want to listen to all decibel events. We just want to listen to decibel events that exceed a certain threshold. And at that point then, that's where the event-driven nature of this is really evident. Because we have a durable connection that's always on, but there might not be any data going through that pipe. And that's okay, it's still on. But when that threshold gets exceeded, the event gets sent down the wire, and the client on the other end receives that event and reacts accordingly. Does that make sense? This is still web development, isn't it? But it's a different kind of web development. Beautiful thing is WebSockets is universally available to you. This is a great website called CanIUse. CanIUse.com. So whenever you're evaluating new technologies like HTTP2, like WebSocket, like the new HTML5 video tag, all of these are the kinds of things you can say, can I use? So when we're talking WebSockets, green is good, right? And this main bar is the current release. But we see previous releases and future releases. So when I see something like this, I'm like, oh yeah, we're using WebSockets. There's no concern about this at all. SocketIO is a really popular library for dealing with WebSocket. You can do raw SocketIO, or excuse me, raw WebSocket kind of things, but most everyone will use some library that'll provide some syntactic sugar. SocketIO is a lovely Node.js library I've used quite a bit. So when you npm install SocketIO, what's interesting is you have both server-side library and client-side library included with that. So on the server side, you can see we're going to bring in Express, that's our web server, and we're going to require in HTTP, that's one protocol, but we're also going to require in SocketIO. And so as HTTP GET requests come in at the root, well, that's fine. We'll go ahead and return index.html. But on connection, IO is SocketIO. When we get an HTTP GET request, we'll do this. But when we get a socket request, we'll do that. And this is how both technologies can live very comfortably in the same server. Ask me again. You said like over a socket the data is encrypted. Yes, the data is encrypted, absolutely. Yeah, so this is a secure way to... The protocol itself. The protocol itself. This is equivalent to HTTPS. Yeah. Very good question. So here's what the application looks like now. I can tell I'm down in the client because I got these script tags, right? So as I bring in the SocketIO client library, I can start doing things like this. I can say, hey, when we submit that form, rather than doing an HTTP post, which is what you'd traditionally do, we can do a socket emit. And what's interesting about that is now we, instead of having more of an email metaphor, we have a real-time chat, don't we? Because this emit will send that message out immediately, and anyone else who's listening for those same events will catch that and do something appropriate with it as well. Where this gets especially interesting is if you have a browser on one person's laptop, a server, and a browser on another person's laptop. SocketIO can make all of this real time. So as one person is emitting messages over here, this person in their browser over there is reacting to those messages. And they haven't instituted anything. They haven't clicked on any buttons. They're not polling. Because we're full duplex and event driven, that magic just happens. So these are two well-established protocols, well-established web protocols. Protocols that were supported and designed and defined by the World Wide Web Consortium. But can we see how they have different usage characteristics? It's not an either-or proposition. We want to use both. We want to use HTTP 1.1 where it's appropriate for all the good caching and things like that. And then we want to use WebSocket for what it's good for, the real-time, event-driven, reactive model of programming. So all of this brings us to Speedy and Quick. But we'll start with Speedy. Speedy was a protocol created by Google, but open sourced, of course, and it eventually is what went on to become HTTP 2. But Speedy had a couple of very specific designs in mind. They really wanted to make sure we could deal with heavy loads. And it might seem counterintuitive that now that we have durable connections, that might hurt performance. Counterintuitively, it improved performance. We'll talk about why. But it also gave us web security. Just like WebSockets are encrypted out of the box, Speedy connections are encrypted out of the box. So we can see how this is simply an incremental upgrade, but we're combining all the prior art ahead of us and trying to use it moving forward. Speedy has got widespread support. Every major browser supports it. You say Microsoft Edge doesn't. It's because this happened during that transition where Edge went on and just supported HTTP 2. Yeah? But even IE supported Speedy. So what this means now is we begin seeing that Google announced Speedy. They're like, hey, this is this experiment we're thinking about using. In 2010, they rolled it into their browser, and they rolled it into all of their web services. So back in 2010, if you were using Gmail, a funny story, you were using Speedy. You probably didn't even know it, but you were using Speedy. If you were watching YouTube videos back then, you were using Speedy. And so after Google proved that out in code, oh look, Twitter enabled it, Jetty enabled it, Apache enabled it, Node enabled it, Facebook, Nginx, right? So we begin seeing that it expanded over time. Now we said the goal of Speedy is to reduce the page load time. This is done by multiplexing. HTTP is a single request response. On the server side, we spun up additional threads to handle it. On the browser, we spun up additional threads to handle it as well. By default, most browsers would open up to 4 concurrent connections to the same URL. So if you had a lot of HTML and a lot of images and a lot of CSS, a lot of JavaScript, the way we solved that is spinning up to 4 threads on the client and spinning up 4 threads on the server and managing things that way. We also came up with clever workarounds like concatenating all of our files together, minifying those files, gzipping those files. But all of these best practices were predicated on the idea that this was connectionless request response. That thing that you do now that's a best practice, concatenate all your JavaScript, minify it, send it down as one bundle, is the #1 anti-pattern you can do in HTTP 2. Because HTTP 2 assumes a durable, multiplexed connection. So what that means now is what we would prefer is you have a bunch of tiny little isolated files. And we would prefer that you request them in a multiplexed way. And as a matter of fact, because that connection is durable and always on, the server can push resources to you even if you don't request them. So we begin seeing a lot of interesting things about HTTP 2. Excuse me, this is Speedy, but I gave away the punchline. It's HTTP 2 as well, right? The other thing Google enforced is they said TLS, HTTPS, security is non-optional anymore. This is required. So we begin seeing where a lot of these modern ideas came out. But again, companies like Yahoo were using Speedy, and this is that same indicator tool that we were talking about. Now, if we went to Google, we would see that it's not only using Speedy, but it's using Quick as well. Now, Quick is for quick UDP internet connections. TCP requires us to acknowledge the receipt of every package. And while that's great for reliability, what we find is it adds a lot of overhead. So just like Google was innovating with Speedy, Google has been innovating with Quick for the past 5 years. If you're visiting Google right now, you're using Quick. And what Quick is basically doing is sending out all of the HTTP responses, secured and everything else, but it's sending them out over UDP instead of TCP. There's a lot of UDP traffic we're getting already. It's common for voice over IP. If you're using Skype or FaceTime or any kind of voice chat, many video applications all use UDP because they want to get those packets there as quickly as possible and handle error correction up in application space, not down in protocol space. So Quick is taking that same idea, but bringing it down to the protocol level. So Quick is in Chrome and Opera right now, and if you wanted to start playing around with Quick, there are a number of Quick servers implemented in Go and Node.js and all manner of other things. This is the second major version of HTTP. It's based on Speedy. So far, so good. The standardization effort was supported by Chrome, Opera, Firefox, IE, Safari, Silk, Edge. All of the major servers have support for this now. Nginx, Apache, Leidy, Tomcat, right? Whatever you happen to be using out of this. We've already seen all the major websites that are using this. We now, if you go out to caniuse.com, we see the widespread support for HTTP2. But here is where it gets interesting. Remember how WebSockets come in over HTTP 1.1 and then they ask for an upgrade? That's exactly what happens with HTTP 2 as well. So you don't have to worry about backwards compatibility. A client will come in and request a connection to HTTP 2, and if they can't support it, we'll certainly fail over to HTTP 1.1. But if they can, we will come in and we will upgrade that connection. This high-level compatibility with HTTP 1.1 is really important. We still support all the verbs. We still support all the headers, all the MIME types, all the everything. This is meant to be an upgrade, and the upgrade includes things like compression on everything. Instead of having to gzip as a configuration tool, all HTTP connections are compressed out of the box. I mentioned that we have server push now. That's a new feature, so you can begin pushing clients down. Loading of all these parallel images over a single TCP connection, but a multiplexed one, is all of the key benefits that we get out of something like HTTP 2. So when we start seeing articles like this, hey, I want to run HTTP 2 over Node.js, it's helpful because you'll do what you'd expect to do. Just like we would do an npm install of WebSockets, now we're going to do an npm install of HTTP 2. We have to deal with keys now. Security is non-optional in HTTP 2. Are you familiar with a website called Let's Encrypt? What does Let's Encrypt do for you? Free TLS keys, yeah. So many times when people are talking about HTTP 2, they will immediately talk about Let's Encrypt as well. Let's Encrypt is completely free, an open source consortium supported by Mozilla and Google and Cisco and all number of things. You should absolutely feel comfortable using Let's Encrypt in production. Now, if your company already has keys, use those instead. But what we're saying here right now is that TLS keys will be required to use HTTP2, and Let's Encrypt is a great turnkey way to get those keys. But once you have those keys in place, you'll require in HTTP2. And by requiring in HTTP2 and creating that server, all of this stuff is baked into this. The automatic failover, the durability, all of those things. But this doesn't look any different than your HTTP stuff that you've already done in Node. So it should be a fairly easy upgrade. But the upgrade will give you a real lift even if you don't use any of these new features. I mean, just the security, just the duplexing, just the compression, all of that stuff will give you a real boost. But then when you start really taking advantage of the capabilities, like push, it enables the server to send multiple responses in parallel to a single request. What this means is when you visit the first page of your app, of course you're going to download all the resources necessary for that. But you might decide as a programmer to pre-download the next page in the series. Even though they haven't clicked on any links, even though they haven't generated any HTTP GET requests, you can push those resources down so when they do click on that next link, your browser will serve it up out of local cache instead of going in over the wire. An incredible performance improvement right there. And this is what it ends up looking like. I'm giving you a Speedy example right here. This example's a little bit dated, but conceptually, architecturally, it's doing exactly the same thing. When you go in and create a server right now, when that response comes in, you'll have the ability to do a response push. And again, that's you sending data downstream that wasn't requested, that wasn't pulled, that wasn't getted. Yeah? But what this means now is you can begin pushing things down. Like in this case, you can start pushing additional JavaScript resources down or those kinds of things. So it's very easy to implement, but very powerful as well. Here's another slightly more advanced example right there that when a request comes in, we'll start pushing down a JavaScript file. And we'll start pushing down another JavaScript file. And so later on, when someone requests it, they will already have it in cache. So it doesn't look any different to us from an HTTP 1.1 perspective, but through that subtle change of push, we've made sure that those resources are in the cache, but everything else continues to behave the way you'd expect it to. I'm sorry? It doesn't end the connection. It ends the connection when you close the tab or close the browser or things like that. But remember, if there are no resources going over that wire, you're not consuming any data or anything like that. Those pipes are durable, but if there's no data going over them, they're essentially free. It's not holding up any resources on the server or anything like that. It's just making those connections available when you want to use them. Good question. Yes, sir?
I see that Android browser doesn't have support for HTTP2.
This might be a dated slide deck. We have to go in and take a look at that. I'd be really surprised. I think what it might have been, if I remember correctly, there was Android browser and then there was Chrome for Android. I think Android browser might have been the one that was lacking support, but Chrome browser, which has been around for the last at least 2 or 3 Android versions, that's the modern version that has all those kinds of things. So I wasn't able to pull it up quickly, but I'm almost certain I'm not lying to you. Yeah? All right.
We need to have support from the application servers also to support HTTP2.
So if I understand your question correctly, I love Heroku. I love being able to say, Heroku push master and go to production. Heroku for a long time didn't support HTTP2, so I had to decide if I liked the convenience of that platform as a service or I wanted a feature. Yes.
Data is coming from application server, right?
Yes.
So can I keep the one HTTP2 connection for the web server to get the static files, and but my REST calls will be still holding 1.1.1?
I'm going to say yes. I don't think you'd want to do that, but I'm going to say yes. That's exactly the idea of what you'd want to do. But if you're hosting a WordPress site, you'll need to start asking, hey, do you support HTTP2? If you're using Heroku, you've got to start saying, hey, do you support HTTP2? Do GitHub pages support it, right? These are the kinds of questions we need to begin asking. I know people are leaving, so very quickly, I hope you enjoyed learning one layer of abstraction below where we do our day-to-day work. We're not going to do this all the time, but just knowing what's out there is making you a better web developer. Thank you so much for your time and attention. I really appreciate it.